Okay. Roll number 2 and 8. Let's start.
A very good afternoon to our respected sir and everyone present here. I, Arijit Das, and my friend Amlan Das is going to present a PowerPoint presentation on IoT Smart Plant Monitoring System. Now we come to the presentation. Slide 1 and 2 are our inaugural slides. Please turn over the slide. Now, we would try to know a bit about smart plant monitoring, that how it would help us. It can help us in some ways, as if we monitor a plant, such as a vegetable or herb garden, it can be controlled by computer. Although farming and gardening have been enhanced with computers and electronic devices for decades, the smart garden often refers to small indoor units that by various means determine when to alert the user to add nutrients. And these smart gardens may also manage their own lighting. Go on to the next slide. Here are the contents that we are going to talk about in our presentation. First, we have the introduction, then motivation, then mission, then objectives, then watering system, then the system that we can use for this type of smart plant monitoring, then some advantages and disadvantages of this smart plant monitoring, and there are some of the how to implement that smart plant monitoring and how the result comes, what is the outcomes, and then we finish our topic. So now starting with the introduction, please move on to the next slide so that I can start the next introduction. Now, what is automation? Automation is the process of monitoring the garden, which can transform garden irrigation process from being manual and static to smart and dynamic. This also leads to higher comfortability, water using efficiency, and less human supervision effort. And this paper proposes, the project proposes a cloud-based Internet of Things, smart garden monitoring and irrigation system using Arduino UNO. Going to the next point, we have the watering requirement for a plant can be adjusted by monitoring the soil moisture, and measuring the soil moisture of the plant gives information if the plant is ideally watered, overwatered, or underwatered, where we can know that if we have to water or we don't have to water the plant. Just go on to the next slide. Now my co-presenter Amlan Das will continue from here.
Now the thing is that motivates us about the project are as we don't have to go outside to water plants. We don't have to actively monitor plants, and also it saves times. It saves water, and also mostly it saves money. Please move on the next slide. Now our mission is to establish a product to help the urban families grow vegetables and flowers for daily use in their background. Roof of the even inside house and taking good care of plants even their absence. Please move on the next slide. The next slides represent some objective that can be possible through the project, and they are customer satisfied through the good quality of products, turn into profits from the first year of the operation. The current unit and international product that will make best selling. Please move on the next slide. Here the watering system, how it's work. After the system it started, The system, it checks water and the soil sensor it wet or not. If it's wet, the process ends. But if this is not wet, then it checks whether it is going to rain or not. Then again the process ends. Now, if neither the soil sensor is wet and nor it's going to rain, then the plants get wetted and then process ends. So this is how the plants are automatically watered by the system. Please move on the next slide. Now, what are the components that are required for this setup? First of all, let's look at the hardware components where we have two sensor section, the monitoring system. Soil moisture sensor is used to detect the moisture in the soil. The sensor is made up of two pieces: the electronic board of write and the probe with the two parts that detect the moisture content of the soil. How does it work? The voltage of the sensor output change accordingly to the moisture level in the soil. When the soil is wet, the output voltage decreases, and when the soil is dry, the output voltage increase. Please move on the next slide. Here ESP8266 Wi-Fi module. The ESP8266 Wi-Fi module is used to give any multi-control access to your Wi-Fi network. It is capable to hosting an application, or it also offered all Wi-Fi network function from another application processor. Each ESP8266 module comes up pre-programmed with an 80 command set. So you can simply how this up to your Android device or get about Wi-Fi ability. The ESP8266 Wi-Fi module is used to transfer the data from Arduino to dummy server and from server to Android. Android board designing used to variety of microprocessor and controller. The board are equality with set and design along option pion and that may increase the value set, including universal serial bus, some molecules which are also used to learning the program from some computer. Please move on the next slide. We have some advantages and disadvantages. It's not smart plant monitoring system. The advantages are: number one, we can predict soil moisture level and mention the broadcast. Number two, irrigation system can be moderated. Number three, damage caused in the product and reduced. Number four, increase the productivity. Number five, water consumption. Number six, profit to farmers. Please move on the next slide. From here, my co-presenter Arijit Das will continue the rest.
Now we have some disadvantages too in this smart IoT smart plant monitoring. The disadvantages are we have some security and privacy related problems. There are too much of technical complexity. There are some connectivity and power dependencies too. Without power, we cannot run the system. And it is also time consuming, means to set up the thing, it's time consuming and it is quite expensive to implement. Please go on to the next slide. Now, this is the block diagram of automatic plant watering system with IoT. Farmer monitors and controls system in order to improve the efficiency and help of sensor parameters like temperature, humidity, soil moisture. Sorry. Please go on to the next slide. So, here are the steps that we need to follow. After the setup is done and how it works. At first, When the power supply is on, the input module of three sensors, DHT22, moisture, start to activate. After that, when sensors get on, it will read the data from soil and from surrounding. According to the values that are detected by the sensors, motor will turn on or off. If moisture is below threshold, then the motor is turned on. If moisture level is high, then it will stop the motor and water supply will also stop. The water will not flow to the plants. If water level is low in tank, then it will also have it will also be detected by the ultrasonic sensor. All the values that are collected from the sensor is sent via ESP8266 Wi-Fi module to ThinkSpeak cloud server, and it is stored in online database via a dummy server. Now uh, this ThinkSpeak cloud server will create the graph for data received by the Wi-Fi module, and then the whole information will show on the Android app. And the user can easily control the motor manually by using the Android app. Go on to the next slide. It's a prototype of the plant monitoring system, that how it will be or how it will look like when the setup is done. Go on to the next slide. We will receive some outcomes that we can notice are there will be reduce in cost and power consumption. We can increase the garden productivity since we don't have time to always look after the garden, and so with this we can easily do the gardening from any place. And this will also provide healthy vegetables at home. It will save the environment from getting destroyed. Move on to the next slide. Now we come to the conclusion of our presentation. In this presentation, we have learned about a system to monitor temperature, humidity, moisture levels in the soil, which was designed, and the project provides an opportunity to study the existing systems along with their features and drawbacks. And agriculture is one of the most water consuming activities. The proposed system can be used to switch the motor on or off, depending on favorable conditions of plants, that is sensor values, thereby automating the process of irrigation, which is one of the most time efficient activities in farming, which helps to prevent over irrigation or under irrigation of soil, thereby avoiding crop damage. The farm owner can monitor the process online through an Android app. Though this project can be concluded that there can be though this project is concluded, there can be a considerable development in farming with the use of IoT and automation. Go on to the next slide. It's a tagline which puts an emphasis to plant trees in order to save our mother earth. Move on to the next slide. Here are some of the references that from where we have collected our data. And move on. And thank you, sir, for your guidance in making the presentation. And thank you, everyone, for giving your precious time and listening to us. Thank you.
Okay, record off करो.